Hello again. We are ready now for Chapter 7, Section 2, titled Ratios and Similar Polygons. And this first slide reads, figures that are similar, and there's the little squiggly line for similar. Figures that are similar have the same shape, but not necessarily the same size. So that's what makes it different from congruent. Similar again, same shape, different size. Now, if you look at this first one, look at triangle 1 as opposed to triangle 2. Notice their general shape is the same, but triangle 2 is just bigger. So again, they have the same shape, different size, so they would be similar. But if you look over to the next triangle 1 as opposed to triangle 3, they do not have the same shape. It almost looks like that angle right there is a right angle. So 1 and 3 would not be similar. And right there, I'll circle that, is the symbol for not similar. Next slide. Similar polygons. Here's the definition that reads, two polygons are similar polygons if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. You need to keep that straight. Have this memorized. Similar. The angles are congruent. The sides are proportional. Now, proportional meaning it's a fraction equal another fraction. With that said, look at the third slide. Identify the pairs of congruent angles and corresponding sides. Well, congruent angles. It looks like angle P is 63 and then angle R. Let's write that down. Angle P is congruent to angle R. And then keep going. Looks like angle N would be congruent to angle Q. Then what's left over? Angle M. That would be congruent to angle T. So again, my angles are always congruent. Now, as far as side lengths go, what about side NP? That's proportional to QR. Keep going. Side MN. That would be proportional to QT. And I can actually put an equal sign in the middle of that. One more, so I'll put another equal sign, one more side. What about MP is proportional to RT? So again, my angles are congruent, side lengths are proportional to each other. Let's do the same thing again. I'm going to write angle B congruent to angle G. Angle C congruent to, match it up, angle H looks like over there. And then finally angle A congruent to angle J. So my angles are congruent. Side lengths. How about AB? Let's just start somewhere, no particular order. AB looks like that goes with GJ. That would be equal to, let's go BC. So find BC. That looks like GH. Then finally my hypotenuse, which would be AC on the first one. That goes with HJ. So those are in proportion to each other. Next slide, number 5. A similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. The similarity ratio of triangle ABC, that's the first one, to triangle DEF, that's the second one, is 3 to 6, which reduces to 1/2. So in other words, if we go from the left to the right, I see a 3 to a 6 every time. But all it says in the next part, the similarity ratio of DEF to ABC, in other words, go the other way, is 6/3, which reduces to 2. So all it's pointing out here is the order in which you have the first one, the second one, will change your fraction or your similarity ratio. That's all it's saying. Let's go to slide 6. It says, determine whether the polygons are similar. If so, write the similarity ratio and a similarity statement. Well, are they similar? To be similar, this 6 corresponds to this 4. So I'm going to write 6/4. That has to equal this 9 corresponds to that 6. 9/6. Well, if I cross multiply, 6 times 6 is 36, and the other way, 9 times 4 is 36. So yes, they are in proportion. So that means yes, they are similar. My similarity statement would just be something like ABCD is similar to EFGH. That's a similarity statement. Next slide. Determine whether the polygons are similar. If so, write the similarity ratio and a similarity statement. All right. Notice the typo right here, because there's 4 letters. If it's a triangle, it's only supposed to be 3 letters. That's a typo. That's not even supposed to be on this slide. So please ignore that. Let's check my angles. Well, if this angle is 36 and this is 10 and that's 10, that tells me that these two angles at the bottom, these base angles, have to be equal. Here's how I figure that out. Remember the rule of 180? If you subtract that 36, that's how much? 4, 17, 144. And if I divide 144, if I divide that by 2, that's 72. That means that's 72, and that angle would be 72. So my angles are supposed to be equal. But if you look, I see a 62 right there. That means these are not similar because my angles are not congruent. So there's a no answer. Let's go on to the last slide. 2 model cars here. Directions say, find the length of the model to the nearest 1/10 of a centimeter. Well, I see my widths. I see a 1.8 there, goes to a 6.3. Well, notice that it's in meters in the top and centimeters in the bottom. Well, remember that 1 meter is 100 centimeters. So 1.8 would really be 180 centimeters. 5 meters would be 500 centimeters. So I have to convert them all to centimeters. That way it's going to work out correctly. So now I'm going to use this 180 over 6.3 because they're in proportion to each other. 180 over 6.3 has to equal this 500, and it goes with my x. So I write 500 over x. Now I cross multiply and solve this. 180 times x I'm going to write 180x equals, I'm going to pick up my calculator, and I'm going to multiply 6.3 times 500. That's 3,150. And then I would divide that to solve it by 180, which would give me x. So divide by 180 on my calculator. 17.5, and that's perfect because it does say nearest tenth. 17.5. How would I label that? That would have to be labeled centimeters. Hey, there's section 2. Thanks for watching.